All right, hello students. Today we're going to be continuing on our exponents unit. We're going to do 9.2 on rational exponents. I'm on the back side of 9.2, should be in the same packet we started yesterday. Just on the quick notes, I'm going to do those first. Okay. For quick notes, it says radicals can be written as rational fractional exponents. Okay, so what that means is the square root of any number, so x in this case, can be written as a fraction exponent. The square root of x is written as x to the power of 1/2. So anytime we have an exponent that is a fraction, it means that it is a root of some kind. Okay, if we want to know what the cube root of x looks like, it looks like x to the power of 1/3. Okay, where the number on the bottom always corresponds to what kind of root we have. Okay, if there's a power on x, like in this case, then that power still stays on the top of my fraction, but whatever kind of root it is goes on the bottom. Okay, so you could turn this into looking like this, or you could go the opposite way also. Okay, in like generalizing this, our power that's on x goes on top of the fraction, and whatever kind of root it is goes on the bottom of the fraction. Okay. Sometimes we can split these exponents up. Okay, so like if I have 16 to the power of 3 over 2, I could split this into just 16 to the power of 1/2, and then all of that to the power of 3. Because if I multiply this back in, I get the same thing, right? Well, 16 to the power of 1/2 is really just like the square root of 16. We know what the square root of 16 is. It's 4, okay? And then I could do 4 to the power of 3. So 4 times 4 times 4, which is 64. Okay, so we can use these, like split them up, put them together, and get to numbers that we can do. We can do the square root of 16. Most of us all have that memorized by now. Okay, and then 4 times 4 times 4, well, you can use those small calculators to do that, even if you didn't know. Okay. And then just a really quick explanation on why the square root of x is 1/2. When we have the square root of something and we're squaring it, those cancel each other out, right? So the square root of 4 squared is 4, okay? And if we have 4 to the power of 1/2 to the power of 2, well, when I multiply those together, I get 2 over 2, right? And 2 over 2 is just 1. So 4 to the power of 1/2 to the power of 2 is also just 4. So that means the square root of 4 and 4 to the power of 1/2 have to be the same because we get the same answer from them. Okay, so because they both give us that answer of 4, these have to be the same. Okay, all right, and that's the basic gist of today. We're just going to practice using this. Okay, so we're going to go back to the front page. This section right here, it is cool to see the proofs, but I'm not really going to go through them. If you want, you can go through them on your own, just so that you know this is false, this is true, and this is true. Okay, so you don't have to do this. If you want to, great. If you have questions, I can answer that when I come back, but we're going to go down to the generalize part. Okay, so in general, a to the power of m over n, okay? That is the same thing. I can split this up, okay, into a to the power of 1 over n, all to the power of n, okay? So I can split this where I put m on the outside and 1 over n on the inside, just like how I did with that example on the quick notes with the 16, okay? Or you could also do the other way around. If it's easier for you to do a to the power of m first, and then do the 1 over n after that, you can do it like that, okay? So you can split this up where you keep the 1 over n and do that first, or you can split it where you're doing the power of m first, okay? But those still exist, they're just, we're gonna do it later, okay? Then also, if we have a to the power of m over n, it looks like this. We got the nth root of a to the power of m, okay? Sometimes people write it like this, the nth root of a to the power of m on the outside. They're the same thing. It doesn't really matter which way you write it. You'll get the same answer. Okay. Simplify each expression using exponents and radical properties. Okay. So we've got 25 to the power of 1/3 to the power of 3 over 2. Okay, I want to simplify this. If you remember from last class, anytime we have a base raised to a power to another power, we're supposed to multiply these two numbers by each other. That is still true. So I'm going to start off by multiplying those two numbers together. I've got 1/3 times 3 over 2. Okay, if you forgot how to multiply fractions, here's how you do it. Top multiplies with the top, so 3. Bottom multiplies with the bottom, so 6. Okay, and then if that simplifies, you want to simplify it, so 1/2. Okay, so my exponent here is going to turn into 1/2. So I've got 25 to the power of 1/2. Okay. Well, I know what 25 to the power of 1/2 is because I can turn this into a square root question, right? This is the same thing as 2 roots of 25 because a fraction is always a root, okay? And we don't necessarily need that 2 because a square root, we typically don't write it. If it's anything other than 2, we do write it. But if it's square root, then we don't have to write it. Square root of 25, we should all know this, it's 5. So 5 is my answer, okay? So even though that looked like a pretty, nasty problem, I was able to do all of that without a calculator, which is the point of these exponent rules, okay? All right, let's do that again. So 16 to the power of 2 over 3, and then divided by 16 to the power of 1 over 6. Well, remember our exponent rules from last time. Anytime we have this, we divide those numbers. When we're dividing those numbers, we subtract our exponents is the rule. So I'm going to take 2/3, and I need to subtract 1/6. Okay. When you're adding or subtracting fractions, remember we need the same base. So right now, or not base, denominator. We need the same denominator. Okay, right now we've got 3 and 6 as our denominator. We need to make this into a 6 if we're going to do this subtraction. So if I'm going to make this into a 6, I need to times that 3 by 2. And what you do to the bottom, you have to do to the top. So I'm going to multiply both of these by 2. So I'm going to get 2 times 2, which is 4, and then 2 times 3, which is 6. So I've got 4/6 minus 1/6. Okay. 4 minus 1 is just 3. So I got 3 over 6. And remember, in addition and subtraction, our denominators never change. Okay. 3 over 6 is the same thing as 1/2. So really, I've got 16 to the power of 1/2. Well, power of 1/2 means I'm taking the square root. Square root of 16 is 4. So that is my answer. All right. On this question right here, I have a negative exponent. And if you remember from last class, we do not like negative exponents. I'm going to get rid of that negative exponent. Okay? I am going to make this into a fraction to make my exponent positive. So this is going to be like 1 over negative 64 to the power of positive 2/3. Now I don't have a negative exponent. I'm good to roll. Okay? In this case, I'm going to split this up like it says over here. Okay, I've got two options. I could keep the 1/3 and put the 2 outside, or I could do the 2 inside and put the 1/3 outside. I'm probably going to make this smaller first if I can. So I'm going to keep the 1/3 inside. Okay, so that's going to look like this. We've got negative 64 to the power of 1/3, all to the power of 2. Okay, that's what this is going to turn into. Okay. Now, negative 64 to the power of 1/3. It is the same thing as like a cubed root of 64. Okay. I need to find a number that when it times by itself 3 times, I get negative 64. Okay. So like something times itself equals negative 64. Okay. It's going to be a smaller number because these get really big eventually. So I'm just going to try. I can try 2 times 2 times 2, see what that gives me. 3 times 3 times 3, see what that gives me. 4 times 4 times 4, see what that gives me. If I do it like that, I do find that 4 times 4 times 4 gives me 64. Okay. Because it's a negative 64, that means it has to be negative 4. So negative 4 times negative 4 times negative 4 gives me that negative 64. Okay. So all that to say that this inside is going to become just negative 4. So it's going to be negative 4 squared. Okay. I found what 3 numbers, they have to be the same, all multiplied to give me 64. That's what this part is. And then that was negative 4, so that square just comes down. And then I can do negative 4 squared. Now I do want to mention all of this is supposed to still be in a fraction, right? We don't want to forget that. So when I do that, I get 1 over negative 4 times negative 4 is positive 16. Okay. All right. Question 2, use positive exponents to rewrite each expression. Okay. So first things first, we're going to split this up. Because they're both being square rooted, I'm going to split this into the square root of 4 and the square root of x. Okay, because we can do different things with them. The square root of 4, we all know what that is. It's 2. Okay. And then square root of x, we want to rewrite it with a positive exponent. So anytime I have a square root, that becomes x to the power of 1 over 2. So my answer is just 2x to the 1/2. Okay, that has been rewritten with just positive exponents. All right. Let's go on to the next one. We want to get just positive exponents here. So we want to get rid of all these roots and cube roots. So let's just focus on this inside first. Okay. Well, y, or the square root of y, is going to change into y to the 1/2. And the cubed root of y is going to change into y to the 1/3. Okay. And if we remember from last time, anytime we're multiplying two variables together, we want to add their exponents. So what's really happening here is I'm taking 1/2 and I'm adding it to 1/3. Now again, when we add two fractions together, they need the same base. Okay, so I need to make these the same. The closest way I can do that is if I made both of them 6. Okay, so to make this a 6, I have to times by 3 on top and bottom. Okay, and to make the 3 a 6, I have to times it by 2 on top and bottom. So I'm going to do that. When I do that, go back to red. Let's see. We got 3 times 1, which is 3, and then we got 3 times 2, which is 6, okay? And then we've got 1 times 2, which is 2, and we've got 3 times 2, which is 6. So I can now add these. 3 plus 2 is 5. So 5/6 is that power, okay? So I've got y to the 5/6. And then that's the inside, what it simplifies to. Then we have the cubed root on the outside. Instead of writing the cubed root, I'm going to put parentheses around this. And instead of a cubed root, it is 1/3, right? Because we can rewrite roots like that. Then, once we have all of our roots, or all of our exponents, excuse me, we want to simplify this as much as possible, so we're going to combine these. Anytime we have a base and an exponent raised to another exponent, we multiply these together. So we get y to the power of 5/6 times 1/3. Or if I keep simplifying that, it's y to the power of 5 times 1, which is 5, and 6 times 3, which is 18. So it's y to the power of 5/18 is my answer. Okay? So as long as you have your rules from last time down, the hardest part of this is actually just like adding, subtracting, multiplying fractions, which we've all done before. It's just we need to review that process, okay? All right, the next one. We've got the cubed root of -64 to the power of -2. I'm going to first rewrite this cubed root as a power, okay? So I've got -64 to the power of -2, and all of that is being raised to the power of 1/3. Okay, now let's combine these. We've got here, we've got -64 to the power of -2/3. Okay. Now let's get rid of our negative because we don't like negative exponents, right? So to get rid of that negative, it's going to become 1/-64 to the power of 2/3. Okay, now it's positive. Now the reason that I wanted to combine these earlier is because I actually want to switch it. I want to make the 1/3 inside and the 2 outside. So I'm going to split this again, but I'm going to split it the other way. Okay, I'm going to split it so that it's 1/-64 to the power of 1/3, and all of that is being squared. See, so it's like the opposite of what I had here. Okay. The reason I wanted to do this is because I know what the cubed root, or sorry, -64 to the power of 1/3 is. We did it up here, okay? So I know that this is going to simplify down to -4, okay? So this is going to become 1/-4 squared. And then I know what 4 squared is. It's 1/16. And that's my answer. Okay. All right, the check your understanding. For these, you're going to need to just either add your exponents together, split them up, do your best to simplify these down. So this one, for example, you'll probably want to split it. Okay, how I would split this is I would split this into 8 to the 1/3, all to the power of 2. Find what number, when I times it by itself 3 times, gives me 8. And then you can just square whatever that number is after to get your answer. Okay? These two, whenever we're multiplying two bases, we add their exponents. So you're going to have to add those fractions together. Okay? This last one, 32, or sorry, C, we can distribute this into all of them. So this would be 32 to the 1/5, and then x to the negative 30 over 5, because negative 30 times 1/5 is 30 divided by 5, and y to the power of 20 divided by 5. The nice thing is, we do have to find what the cubed root of 32 is, or not the cubed root, the fifth root of 32 is. But as far as these exponents go, well, I know what 30 divided by 5 is, right? That's 6, so this is x to the negative 6. And 20 divided by 5 is 4, so this is y to the 4th. So really, now all we need to do is figure out what number, when I times it by itself 5 times, it's going to give me 32. And then I need to get rid of any negative exponents, okay? Little hint, this is going to be a really small number because I've got to times it by itself 5 different times, and it doesn't get very big, right? Only 32, so think really small when you're trying to figure this one out. Okay, and then more practicing over here with just positive exponents, so changing it from that square root into an exponent, okay? And just get it as simple as it can, and then make sure everything's positive. All right, I'm going to leave these questions for you to try on your own, because the more you practice this, the better at it you're going to be. It's not going to be very easy at the beginning. And then when you get done with this, you've got Delta Math online.